A fundamental question is now being asked in boardrooms and government offices across the globe. What happens when China no longer requires American technology? The fact is, a decisive shift has already occurred, largely unnoticed by the public. China has severed the technological dependency that granted the United States significant leverage for over 3 decades, a leverage built on semiconductors, intellectual property, and export controls predicated on the assumption that China could not achieve advanced technological independence. That assumption has now been proven false. What's critical to understand is the nature of the Chinese response. The moment the United States moved to freeze China out of advanced chip markets, Beijing initiated a degree of national coordination that reportedly surprised even its own strategists. Contrary to widespread analyst predictions of China falling behind, the opposite transpired. The country constructed backup supply chains, mobilized entire provinces into specialized research zones, and compelled its corporations to develop substitutes for every critical American component. For years, this monumental effort remained off the global radar. Today, the results are undeniable. This analysis will detail how China converted sanctions into a strategic catalyst. We will examine decisions made years ago that are only now revealing their full impact, and explain why Washington is confronting a strategic challenge for which it was unprepared. We will also investigate the lesser-known mechanisms of China's tech push: internal technology reserves, shadow supply networks, and domestic projects once dismissed as failures that have since proven their worth. This is not merely a story about computer chips or consumer gadgets. This is about who will control the next era of computing, artificial intelligence, and global digital infrastructure. It is a rivalry that is no longer one-sided. It is about what occurs when the world's most rapidly expanding technology ecosystem ceases to need permission from the established leader. For many years, American technological dominance was unquestioned. The United States controlled the most advanced chip designs, the essential software platforms, and the highly specialized machinery required to build modern electronics. Silicon Valley set the global standards. This position allowed Washington not only to lead the market, but to shape international behavior through rules, patents, and access to technology. The tools of this influence were potent: sanctions, export controls, and strategic alliances. When the US restricted access to a key chip or piece of machinery, entire industrial sectors could falter. This created a form of leverage that few nations could counter, with even close allies often compelled to fall in line. Dependent as they were on American patents, software, and semiconductor technology, China was no exception. For decades, its industry was built on American-designed chips, American cloud systems, and American engineering tools. Factories required US-approved equipment. Developers operated on US-owned platforms. This reliance created a profound structural vulnerability, one that China's leadership recognized all too well. When Washington decided to tighten its control, it aimed squarely at the heart of China's technological ascent. The US cut China off from the most advanced chips, the very engines of artificial intelligence and high-performance computing. The message was unambiguous: slow China's progress by controlling the essential tools of innovation. The pressure campaign intensified. Washington successfully lobbied allies to restrict sales of advanced lithography machines from firms like ASML, the only source for the equipment needed to produce cutting-edge semiconductors. With this machinery off-limits, China's capacity to manufacture top-tier chips appeared to be permanently constrained. The belief in Western capitals was that this would set China back by years, securing a lasting US advantage in everything from data centers to military systems. Major Chinese firms, such as Huawei and ZTE, were directly targeted. facing crippling bans and being blocked from key components. The objective was clear: to isolate China and curtail its rise in the fields that will define the next century. However, the outcome was not what was anticipated. Instead of slowing down, China declared a state of national technological urgency. Universities expanded their semiconductor programs overnight. Provincial governments directed massive funding into research laboratories. Companies were tasked with developing replacements for banned American technology, starting from first principles, if necessary. Entire supply chains were reconfigured to reduce foreign dependence. The very sanctions designed to contain China had in fact accelerated its resolve to achieve self-sufficiency. What we witnessed was not merely a policy response, but one of the most comprehensive technological mobilizations in modern history. Beijing's strategy was systematic and lavishly funded. The state injected billions into semiconductor research, establishing a coordinated network of new laboratories, university programs, and specialized institutes. This was not a scattered grants program. It was a targeted, sustained national project designed to create an entire research ecosystem insulated from external pressure. Practically overnight, cities like Shanghai and Shenzhen were transformed into advanced technology zones, actively recruiting engineering talent from across the globe. Concurrently, a national campaign to replace foreign technology was launched. This was far more than a political slogan. It became a concrete directive for industry. Manufacturers, software developers, and hardware designers were compelled to shift from American products to local alternatives. We saw government agencies migrate their entire computer systems to domestic processors. Telecom giants undertook the complex task of redesigning network equipment to use components built exclusively within China's borders. The push extended into the most challenging fields: artificial intelligence, novel chip architectures, and advanced lithography, areas where China was predicted to lag for decades. Research teams focused on redesigning processors to circumvent American patents, while local firms competed to develop a new generation of AI chips independent of Western hardware. Quietly and with remarkable speed, China began constructing parallel technological ecosystems. Smartphone companies expanded their own operating systems. Cloud giants built domestic alternatives to American platforms, supporting millions of local businesses. A new self-contained semiconductor supply chain emerged, connecting everything from raw material miners to chip designers under a single coordinated national network. Step by deliberate step, China was building a complete technology universe designed to function under the most severe foreign restrictions. The clearest symbol of this unexpected progress was Huawei. Written off by many analysts after being cut off from advanced chips, the company instead unveiled new, sophisticated processors. This achievement signaled a profound shift in China's technological capability, demonstrating that it could advance even without access to the most cutting-edge foreign hardware. Other domestic chip makers followed, achieving the production of 7-nanometer chips, a milestone few thought possible for China under such restrictions, and began exploring even more advanced nodes. This momentum cascaded into artificial intelligence. Chinese AI systems, once wholly dependent on hardware from firms like NVIDIA, began training on locally developed processors. Data centers were upgraded with domestic accelerators, allowing China's research community to continue its work without American suppliers. The cumulative effect of these advancements has been a steady reduction in China's dependence on American technology. Companies swapped foreign cloud platforms for homegrown versions. A mature local chip ecosystem now supports industries from smartphones to electric vehicles. The structural vulnerability that once defined China's tech sector has begun to fade, replaced by a tangible and growing self-sufficiency. This shift has not gone unnoticed on the global stage. Across Asia, Africa, and the Middle East, a quiet realignment is underway. Nations that once relied exclusively on American technology are increasingly turning to Chinese alternatives. Telecom operators are adopting Chinese 5G equipment. Governments are installing data centers built on Chinese hardware. The appeal is clear. These systems are often more affordable, reliable, and crucially, perceived as free from the political conditions that can accompany American technology. This trend has sparked a serious concern in Western capitals. America's long-standing strategic weapon, the ability to exert influence through technology control, is seeing its reach diminish. When nations have a credible, full-service alternative, Washington's leverage naturally weakens. Export controls and sanctions lose their bite. China is no longer just a manufacturing hub. It has developed an unusually complete technological stack, its own chips, its own AI, its own cloud services and networks. A country seeking to modernize can now procure an entire digital infrastructure package from China without a single American component. This level of integration confers a strategic advantage that few in the West anticipated. Consequently, recent American attempts to slow China's progress are showing clear signs of diminishing returns. New rounds of restrictions are announced, yet China's technological roadmap appears largely unaltered. Domestic research continues apace, international partners continue to buy Chinese systems, and local industry is deepening its use of homegrown technology. The very pressure designed to derail China's ascent is now struggling to alter its long-term strategic direction. What we are observing is a fundamental recalibration of global power. As China's technological self-reliance has deepened, the United States has begun to confront a series of unforeseen challenges in domains where its dominance was once unquestioned. One of the most significant shifts is visible in the realm of trade and diplomacy. For years, access to America's advanced technology served as a powerful bargaining chip, allowing Washington to shape international agreements and influence policy. Now, with credible Chinese alternatives readily available, the threat of withholding that access has lost its potency. Negotiations that were once heavily weighted in America's favor have become more balanced, and in some instances, far more difficult for Washington to manage. Simultaneously, the enforcement of export controls has become a vastly more complex endeavor. While the U.S. can restrict its own corporations, it cannot as easily prevent third-party nations from engaging with China. Suppliers across Southeast Asia, the Middle East, and Europe have become adept at finding workarounds, reconfiguring supply chains, or subtly modifying products to bypass American restrictions. These loopholes have systematically diluted the impact of Washington's sanctions, and with each passing year, new methods emerge, steadily eroding the United States' ability to strategically isolate key Chinese industries. A further consequential trend is the gradual international adoption of Chinese technological standards. We see telecom operators implementing Chinese 5G architecture, consumer electronics manufacturers integrating Chinese semiconductors, and infrastructure projects in developing nations being built upon Chinese data frameworks. These standards are gaining traction not merely for political reasons, but because they are often more affordable, scalable, and easier to deploy than their Western counterparts. As more countries align with this technological ecosystem, the United States is finding it increasingly difficult to promote its own standards as the global default. The cumulative effect of these shifts is the very real prospect of a bifurcated global technological order. One block built around American systems and patents, another coalescing around China's expanding digital ecosystem. This division would have profound implications, affecting everything from cybersecurity protocols to global supply chains, creating a world where devices, software, and communication networks no longer operate within a single shared framework. Now, it is crucial to be clear, China is not surpassing the United States in every technological category. However, one fact has become unmistakable. China is no longer exposed in the way it once was. The era when a single American export ban could cripple a critical Chinese industry is receding into the past. China now possesses its own chip makers, its own cloud giants, its own AI leaders, and its own hardware supply chain. Even in areas where it still lags, the gap is no longer defined by a state of dependency, but by the dynamics of competition. This fundamental shift alters how every nation calculates technological risk. A state that can rely on its own foundational systems cannot be coerced in the same manner as one that is reliant on foreign supply. We are, therefore, witnessing the emergence of a multipolar technological landscape. For decades, the digital world orbited around American companies, American patents, and American platforms. That era is over. Nations now have genuine alternatives. Some will align with American systems, others with Chinese, and many will pursue a hybrid approach. New technological blocks are forming, driven not solely by economics, but by politics, security interests, and national strategy. Europe is forging its own regulatory and industrial path. India is aggressively pursuing its digital ambitions. Smaller nations are making calculated choices based on cost, speed, and reliability. This new landscape sets the stage for what may be the defining strategic race of this century. The coming decade will determine which nation or group of nations leads the digital future. Breakthroughs in advanced semiconductors, quantum computing, artificial intelligence, and cybersecurity will be decisive. Each development will shape how data flows, how industries function, and how governments project influence on the world stage. The decisions being made today in research laboratories, policy units, and corporate boardrooms will establish the balance of power for a generation. China's journey from technological dependency to resilience has irrevocably altered the global balance of power. The nation that once relied on foreign chips, foreign patents, and foreign systems has now carved its own path. And in that achievement lies a lesson far greater than any single rivalry. When a nation can survive without its competitor, it ceases to be controlled by it. The world now watches as two technological superpowers advance on parallel tracks, each constructing the systems, standards, and strategies that will define our future. The next chapter will determine whose technology shapes global industries, whose networks connect the world, and whose vision ultimately leads the digital age.